Okay, now we're going to look at some problems involving compounded interest. You can see the formula has an extra variable in it, this n, and all the other variables, your p is still principal, r is still your rate as a decimal, time is still your length of time, usually in years unless it says otherwise, but n is the number of payments you receive per year. Basically, in compounded interest, you're going to get interest on your interest. So if we look at number 4, still have a principal of 4,000, a 6% rate. So if R is 6%, I've got to move that decimal over twice. So that's 0.06. Compounded quarterly, that word quarterly means 4 times a year. Pretty much every 3 months or 4 times a year. And then after 5 years, so T is 5. So same thing we did earlier, but 4,000. It's still 1 plus because it's interest increasing. I still do the rate, but that rate has to be divided up into 4 payments. That 6% is going to be split into 4 equal parts. And then the amount of time in years is going to be 5. But the good news is my interest gets split up, but instead of just getting 1 payment per year, I get 4 payments each year. So that's why it's 4 times 5 in that formula, because 4 payments a year times 5 years will be a total of 20 payments. Now, once again, you can simplify some of that, or you can just type it into Desmos exactly as is. I'll go ahead and pause the video, give you a chance to try that, then we'll look at it together. Okay, so as we go over to Desmos, you can see that I got it typed in pretty much exactly as it was. And then once again, unless it says otherwise, to the nearest cent for these problems involving money. So that should have been 5,387 and 42 cents. So one other thing I did want to mention that you've probably already discovered if you attempted this is if you try to type this in your exponent as a, let's see, as a 4 times 5. Sorry, I'm going to have to get my mouse working properly. As soon as you do that times, it kicks you out of the exponent. So you have 2 options. You can either go ahead and simplify 4 times 5 yourself to a 20, or you can do 4 parentheses 5 like I did, which is still understood multiplication. But for some reason, the way Desmos is programmed, it won't take the multiplication and let you keep that in the exponent. Unless, let's see, if you open a parenthesis in front, that's another way you can get it to keep the exponent. But I really like the way we had just done it, where I just do the 4 parentheses 5 and it gets everything the way it needs to be. Let's go ahead and look at that other problem. This one, very similar. We have a p-value, a starting value of 6,500. The interest rate is going to be 8%, which is 0.08 after I move the decimal twice. This time monthly is 12 times a year, so n is 12, and my time is 7. So that means I should have 6,500 times 1 plus 0.08 divided by 12, because that's being split up into 12 different payments, that 8% interest. And then my exponent is 12 times 7, because I'm not just getting 1 payment every 7 years, I'm getting 12 payments for each of my 7 years. So 12 times 7 for the exponent. You can go ahead and put that in Desmos, remember to round to the nearest cent, and let me know if you have questions on these problems.